This video, I'm going to go through our notes for lesson 2.4, and it says solving an inequality with variables on both sides. This would maybe be better titled solving multi-step inequalities. Because we are adding multiple steps and we're looking at variables on both sides, we're going to need to do some distribution. It's really all of the things that we did in chapter 1, but now instead of having equations or equal signs, we have inequalities. So it might be a good idea to start, if you're struggling with this section, to kind of go back and think about these few problems from chapter 1. How do we solve these same things when it's just equations? Because the process with inequalities is going to be exactly the same. So what I would recommend is pause this video, see if you can go through these on your own. We'll go through those together before we get into the inequalities. So this first equation, we're trying to remember, when we solve an equation, our goal is to get that x value or whatever the variable is by itself. We want to get that, in this case, x equals something. That's my goal, right? So I always think of, if I'm trying to get x by itself, I got to get rid of this plus 2 and I got to get rid of this 4. We always want to do this one further away first. It's just going to make our life a lot easier. And we're always doing the opposite, right? So since this is a plus 2, I'm going to subtract 2. And then, remember, if I do it to one side of the equation, I have to do it to the other side of the equation. The whole reason we did this is because 2 minus 2 is 0. That goes away. I've got 4x equals 12. Now what we need to remember when we get to this point is that 4x means 4 times x. So if I want to do the opposite of multiplication, that's going to be division. If I divide this by 4, I have to also divide this by 4. So that means x equals 12 divided by 4, which is 3. When we move into this equation number 2, this is different because I've got x values on both sides of the equation. Okay, so what that means is the first thing I need to do is I need to get everything with an x value to one side of the equation. Doesn't matter which side. And I need to get everything that's just a number value to the other side. So I always start with the variable first. I just find that it works out better and it's easier. So I either need to subtract 5x from both sides, because that would make this one go away, or subtract 7x from both sides. And either one would work. I generally prefer to subtract the smaller value because that means my x values are going to remain positive. So see what I mean here? This would be 3 equals 2x plus 25. If I had done it the other way, I would have ended up with negative 2x on the left. So all my x values are over here now. That means I need to get rid of this. So I'm going to subtract 25 because that's a positive 25. And we end up with negative 22 equals 2x. Final step, just like before, remember 2x means 2 times x. Divide by 2, divide by 2. X equals negative 11. Final one. What we need to remember here is that this is distribution. Okay, when I have the stuff inside the parentheses and then the number right outside, that's 4 times everything inside. So let's multiply that. 12 equals 4 times 2x is 8x minus 4 times 3 is 12. Add 12 to both sides. So I've got 24 equals 8x. 8x means 8 times x. We do the opposite by dividing. X equals 3. So the only thing that's different now is we have inequalities. We're still solving exactly the way that we did in chapter 1. We can still end up with no solutions or infinitely many solutions. We're still doing everything we did already in chapter 2, and the only thing we really need to watch out for is when we multiply or divide by a negative, we need to flip our inequality. That's it. So I'm going to solve this exactly the way that I would if that was an equal sign. I've got plus 7 here. I'm just going to rewrite the problem because it makes it easier to show my work, I think. So again, my goal is still to get the variable by itself. I've got plus 7, so I'm going to subtract 7. It's still from both sides. Now it's not an equation, but both sides of the inequality. So I've got y over negative 6 less than 2. Now, again, I've got y divided by 6. So if you just say that to yourself, say, what do you see? Y divided by 6. So to undo divided by 6, I need to multiply. That's actually a negative 6, so I need to multiply by negative 6. Since it's a fraction, I like to keep it all as fractions. Negative 6 is the same as negative 6 over 1 times negative 6 on this side, and we end up with y is less than negative 12. And I took up a little too much space there. I can probably squeeze a graph in here, tiny little graph. Got my line, negative 12, and since I want to graph these y values, and those y values are less than negative 12, I want everything over here. Remember, what this means is that everything that I graph is a solution to the equation. If I plugged one of these numbers in, like negative 13 or negative 20 or negative 100, if I plug that in for y, it would make this whole thing true. All right, moving on to part B. Again, solving the exact same way. Let me just rewrite real quick. 2v minus 4 greater than or equal to 5. Add 4 to both sides. 2v is less than or equal to 9. Divide by 2. And we get v is less than or equal to 4.5. So for my graph, I've got 4.5. Let's clean that up a little bit here. And now I've got v is greater than or equal to, so that's closed dot because it could be 4.5 or it could be anything bigger than 4.5. All right, moving on. Here we got variables on both sides. So again, we treat it just like if it was an equation. I want to get both my variables to the same side and then get x by itself. And again, in order to try to keep my variables positive, I'll subtract the smaller one. So I end up with 4x, then minus 5 is still there, 11 on the right. Plus 5 to both sides. 4x is less than 16. And divide by 4. X is less than 4. Since it doesn't ask us to graph it, we won't. Final two examples. Here we'll get into some interesting cases. We've got a little distribution to do. Not a bad idea to maybe just try this on your own, see what happens. 8b, 8b minus 3 is greater than 4 times 2b plus 3. Let's do our distribution first. So that means I'm going to multiply here. Everything else is going to stay exactly the same because I can't combine any like terms on the left. So that's 8b plus 12. Now, when I try to get all my variables on the same side, notice what's going to happen. They're both the same value. Anytime they're the same value, what's going to happen when I subtract? They both go away, which is fine. Just notice what we have left. Negative 3 is greater than 12. So just like when we had an equation, when the variables go away, we have to look at this and ask ourselves, is this true or is it not true? Is negative 3 greater than 12? No, it's not. So that means that this is false, and therefore there are no solutions. Okay, so kind of like, exactly like when we had equations, if the variables all cancel out, right, or basically they go away during that solving process, if that happens and we end up with a false statement, what that tells us is that there are no solutions. Let's look at the next one. Again, we've got to do some distribution. And I'm just going to do that distribution as I rewrite this time. So 10w minus 2 times 1.2 is going to be 2.4. It's less than or equal to 7 plus 10w. So again, notice we're going to end up in that same case because I've got the same variable here, minus 10w, minus 10w. The variables both go away. Negative 2.4 is less than or equal to 7. Now I've got a true statement. So again, just like when we had equations, if the variables all go away and I end up with a true statement, that means that I have infinitely many solutions. Okay? Meaning that I could plug in literally any number for w, and it will make this entire thing true. Okay? And you could try that. I mean, you could try, it might be easier to go down to here because this is just a simplification, but plug in any number you can think of for w, and this inequality will always be true. Okay, so this is that other case where variables cancel out. Meaning there are no variables left in my inequality, and I have a true statement. That means that there are infinitely many solutions. You could plug in any number for w, and you will end up with the correct answer. I'm just going back and peeking because for some reason I thought we had a sign flip in here, and we do, and I missed it in my previous explanation. It just dawned on me that I needed to go back and look for this, and it is in this example right here. It was in this very first example. I multiplied by -6, and I never flipped my sign. So I apologize. It's very easy to do, right? So that happened right here. When I multiplied both sides by -6, whenever we multiply or divide by a negative number, you need to flip that sign. Okay? So I'm going to change this to greater than -12, which also means that our graph needs to flip. We want all of the values greater than -12. Now I'm worried I made another mistake. Nope, everything else looks good.